application of set theorem Venn diagram. An example: in Asmia Sango Secondary School, there are 174 students in Form 3. Of these, 86 play table tennis, 84 play football, 94 play volleyball, 30 play table tennis and volleyball, 34 play volleyball and football, and 42 play table tennis and football. Each student plays at least one of the 3 games. So we have to illustrate this information on a Venn diagram. Then Roman 2, write down the equation in x and find x. If a student is chosen from Form 3, what is the probability that he plays 2 games? So here we have to arrange this. The cardinality of universal set is 174, which means that the total number of students is 174. Cardinality of student playing table tennis is 86, and the cardinality of football is 84. Cardinality of volleyball is 94. Cardinality of table tennis in the section volleyball is 30. Then the cardinality of volleyball in the section football is 34. Then cardinality of table tennis and football is 42. So we have to illustrate this information in a Venn diagram. So we draw our Venn diagram, and it's usually rectangular shape. So this is the Venn diagram, as you can see. And the cardinality of this Venn universal set is 174, which means the total number of students is 174. So we have to draw a Venn diagram, and we have 3 intersecting circles. So 1, 2, this one, then this one, and also this one. So for this we call this one T. It's table tennis. Then we have what? Football, F, and lastly we have volleyball, which is D. And the cardinality of table tennis is 86. So right here, 86. Football is 84. Then volleyball is 94. Then there is a hint to tackle this one. Always start with the three intersecting circle, or where the 3 intersect. For example, it is here. So we put here x. Then we come to where 2 intersects, that is table tennis and volleyball intersect here, it is 30. So T. And here is x, so it will be 30 minus x. Then here it will be volleyball and football, 34 minus x. 34 minus x. Then here is 42 minus x. 42 minus x. So we have to illustrate this one on a Venn diagram. So write down the equation in x and hence find x. So Roman 1, illustrate the information on a Venn diagram. We have illustrated the information on a Venn diagram. So we go to Roman 2. Write down the equation in x and hence find the value of x. So I'm going to introduce a constant here. Let me say A, B, C. So I want to know the exact number of students who plays table tennis. I call it A, B, C. So for this A, the total number, the number of students who only play table tennis, and B, the exact number of students who play football, and the exact number of students who play volleyball. So if I sum this one now, A plus this 30 minus x, then plus x plus this is 42 minus x for this part, which it should be able to give me 86. Right there, 86. For instance, so we have A, and then minus x plus x and x will go. Then we have A, then minus x. Then here we have 30 plus 42, that's 72. Now 72, 86 minus 72. 72 get 14. And I call this one equation 1. So for equation B2, let's say B plus 30 minus x, then plus x plus 34 minus x. It should be able to give me 84. You are also so it's B plus 30 minus x plus 34 minus x is equal to 84. Then minus x plus x, it will cancel out. So we have 30 plus 34. It's b minus x is equal to, it is 64. 84 minus 64. We get 20. Here is 30 plus 34, it is 64. Now 84 minus 64, it is 20. So I call this one equation 2. Then for equation 3, I'll take for c. It is c plus 42 minus x plus x plus 34 minus x is equal to 94. Then this one will also cancel. So we have 42 plus 34. That is 76. Now it's c minus x is equal to 94 minus 76. 76, so we have 18. Now I call this one equation 3. But right here now, equation 1 is a minus x is equal to 14, and b minus x is equal to 20. C minus x is equal to 18. So for this part, let me say I add this one, a plus b plus c. Then if I add minus x minus x minus x, it will be minus 3x is equal to, this one is 34 plus 18, 52. I call this one equation 4. Then if I add also this one, a plus b plus c, that is a plus b plus c plus 34 minus x plus x, then plus 42 minus x plus this 34 minus x, it should be able to give me the total number of students, which is 174. So for this part, x and x will cancel out. Then you have 34 plus 42 plus 34. So 34 plus 42 plus 34. 34 plus 42 is 30. 30 plus 42 plus 34. 30 plus 42 plus 34. Get 106. So it will be a plus b plus c. Then minus x minus 2x is equal to 174 minus 174 minus 106. 174 minus 106 get 68. I call this one now equation 5. Then I subtract equation 5, subtract equation 2. I will rearrange a plus b plus c minus 2x is equal to 68. Then subtract a plus b plus c minus 3x is equal to 52. So if I subtract this one, it will be 0. Then minus 2x minus 3x is equal to 68. 68 minus 52. And the answer is 16. So minus 2x minus 3x, it is x. X is equal to 16. I have obtained the value of x. Then we go to, if the student is chosen at random from a form 3, what is the probability that he plays 2 games? So for 2 games, you can see here is 30 minus x. So for 2 games we have 30 minus x, then plus 42 minus x, 42 minus x, then plus 34 minus x. So you can see it is where we have 2 games, table tennis and football. We have volleyball and football, and we have table tennis and football. So I add this one. So 30, but x is 16. So 30 minus 16, that is 14, plus 42 minus 16, that is 26. Now plus 34 minus 16, that is 18. Now if I sum up this one, 14 plus 26 plus 18, that is 14 plus 26 plus 18, the answer is 58. So the total number of students who play 2 games are 58, but the total number of students in that school, in that Form 3 class, is 174. So 58 over 174, we get the exact probability of students who take 2 games. It is 58 divided by 174, and the answer is 1 and a third. So the probability of students that play 2 games is 1 and a third. So if you have not subscribed to my channel, please subscribe to my channel so that if I produce another new mathematical theorem, you can see and solve. So it's simple, follow this step, and remember, always start with the 3 intersecting, where the 3 intersect, like here. So be blessed, have a lovely night.